our next lesson is on the intermediate value theorem. This is a theorem that once you see a numerical example, you're going to think, oh, this is just common sense. It's kind of like knowing that 2 plus 3 is 5, so therefore 3 plus 2 is 5. It's just common sense. So it sounds kind of confusing when you read this definition, but I promise it's very, very simple. So here's what it says. It says if f of x is continuous on the closed interval from a to b, and k is a number between f of a and f of b. So these are output values. So k is talking about an output value here, and so they kind of should have this right here, but they're saying k is some value between f of a and f of b. Then there has to be some number c in our interval such that f of c, or the output value of the function, is equal to k. Well, in the picture they have drawn here, there are 3 places. If this is k, there are 3 places. But even if the function was just a line, like if they were talking about, here's f of a, down here is f of b, and if it were just a straight line, and k is some value between f of a and f of b, it's going to have to cross at least once, and that's all it's saying. There's got to be at least one place, if the function is continuous, where it crosses. Now sometimes this value that they're talking about is 0, like the x-axis, but it could be any k value. That's as long as that k value is between these other outputs. So let's look at an example down here and see what they're talking about. They want us to show algebraically that there's a root of the equation between 1 and 2, and they give us this equation. So here's all we have to do. Let's find the f of a and the f of b, or the output values. So f of 1, so 4 times 1 cubed minus 6 times 1 squared plus 3 times 1 minus 2. So when I plug in 1, let's see, I'm going to get 4 minus 6 plus 3 minus 2 is negative 1. And so that's f of a. F of b, in our case, b is going to be 2. So 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2. We have 2 cubed is 8 times 4, 32, minus 4 times 6 is 24, plus 6 minus 2. So 32 minus 24 plus 16 minus 2 is 12. All right. So what it asked was, is there a root? Well, a root has that k value would be equal to 0, right? The output value on the x-axis is 0. So all we have to know here is that our output went from negative 1 to 12. Or if I were graphing it, my graph, when x is 1, I was at negative 1. When x was 2, I got positive 12. So therefore, this graph has to have a root. It has to go through 0. So because f of 1 was negative 1 and f of 2 was 12, there is a root, or a 0, between 1 and 2, when x is 1 and 2. I'm sorry, you couldn't see what I was writing again. Because f of 1 is negative 1 and f of 2 is 12, there has to be a root, or a 0, between 1 and 2. And that's all there is to it. Test these values, see if they're on opposite sides of the k value they're asking you to find. All right, so in this next example, they're asking us to find the value of c such that f of c is 25. Well, remember up here that f of c represented our k value that we were looking at. So all they're saying here is that we want to know if k, or the output, is 25, then where is this function? Where does it cross? And so I went ahead and plugged this into the calculator, so I'm going to show you real quick. Real bad glare on that. Alright, so here's the equation, just typed into y equals. I've already reset the window just so you can get a sketch of it. It's just a cube function graph. And so what they're asking is, okay, well, what if the output, or the y value, was 25? It just wants to know, what is this? So let me sketch that for us. We've got this cube function graph, and then we got the line at 25 here. It wants to know where they cross. And so this one actually, I mean, if we wanted to solve it, what we're doing here is we have our function f of x equals 4x cubed minus 6x squared plus 3x minus 2, and then this other function is just 25, and they want to know where these are equal to each other. So they really didn't give us one that was very nice to solve, because we can't really, we'd have to do some synthetic division and stuff. So we're just going to do the calculator. So if you have Desmos, well, actually don't use Desmos. Get used to using your TI, because that's the one you're going to have to use on your test. But use that TI-84 app we have. We want to find this intersection up here. So you need to graph the equation that we were given, and then graph the line y equals 25. We're going to find the intersection. So second trace 5, enter, enter, enter. And it looks like that intersection is at 2.378. So when k has an output of 25, the x value here is at 2.378. All right, so this last example is a good example of how they could ask you a test question over this, because it seems fairly obvious, like I said, that if the output values are on either side of that number, it's just seems pretty obvious. But here's a question that you have to think about a little bit that does involve the intermediate value theorem. So it says that function f is continuous on the closed interval from 0 to 2. So it is a continuous function within this little section of the table they've shown us. And it has values that are given in this table. It says the function f of x equals 1/2 must have at least 2 solutions in this interval for this function if k equals what? So probably the best way to go about this problem would be to maybe sketch a graph of the points that we do have. So let's look at what we've got. We got 0, 1. We've got 1, and then this k value that we got to decide upon, and then we've got 2, 2. All right, so we know that the function is continuous between 0 and 2, so between these 2 points. And if I were to draw a straight line in between the 2, we wouldn't go through 1/2. Remember, 1/2 is going to be a line down in here, right? So we want this function to have to dip down and go through that line. It says twice, at least 2 solutions. So for that to happen, it's got to dip down below and come back up. And we don't know how far below. It doesn't really matter. But it's got to go below that 1/2 line so that it will cross it 2 different times. So let's look at our options here for k. So if k were 0, if the output were 0? Well, that seems right. Because if k is only 1/2, then we're only going to come down here and hit it one time, right? This would only let it hit once. If k is 1, then it's not going to hit it at all. It will never come down. So none, none, and none. So this has to be our k value.